video, we'll use logistic regression to solve a binary classification problem. We'll walk through an example predicting loan approvals based on features like income, credit score, and more. To do this, first we're going to need to import the necessary libraries for analysis. Now we'll work with a loan approval dataset. In the next cell, we're getting the dataset from Kaggle and then unzipping it. We'll load the data into Pandas data frame and then print some information about our dataset. So let's look at the output. We can see that features like person income, credit score, loan percent income, and our target variable loan status, which is either 0 for rejected or 1 for approved. The shape shows we have 45,000 examples to work with, which is actually a good amount of data for a model. The summary statistics show the distribution of our numerical features, and we've confirmed there are no missing values in the dataset. Now we need to understand the data. Let's visualize the distribution of our target variable to see if our dataset is balanced. We can also check out some of the box plots of how some of our features relate to the target variable. First, we're going to explore the target variable distribution. And now we're going to explore the relationships between features and the targets. We'll do income versus approval. Now we'll do credit score versus approval. And then last, we'll do DTI versus approval box plot. So the bar shows us the distribution of approved versus rejected loan applications. There are 35,000 rejected and 10,000 approved. The classes are unbalanced, which is not ideal for building a classification model. These box plots show the relationships between our three main features and the loan approval status. Looking at the first plot, we can see that the applicants with higher income don't necessarily get more approvals. The middle plot shows that the credit score distributions are very similar between the two classes. And the third plot shows that the lower debt-to-income ratio, loan percent income, tends to result in fewer approvals. Now we're ready to apply logistic regression. We'll start by prepping our features and our target variable. For features, we're selecting person income, credit score, and loan percent income. Our target variable is the loan status. Let's prepare our features and target. Now we'll split our data into training and testing sets using the 80-20 split. This means 80% of the data will be used to train the model. 20% will be held to evaluate the model's performance. The random state parameter ensures reproducibility. Since our features have different units and ranges, income in dollars, credit scores around 500 to 850, and loan-to-income ratio as a percentage, we need to standardize them and to have zero mean and unit variance. This helps the model converge faster and prevents features with larger scales from dominating the model. So we're scaling the features. And now we're creating and training our logistic regression model using the scaled training data. We'll create and train the logistic regression model, and now we'll print. Let's take a look. The model has been trained, and now we can see the coefficients for each feature. These coefficients tell us how each feature affects the prediction. A positive coefficient means the feature increases the probability of approval. A negative coefficient means the feature decreases the probability of approval. The magnitude tells us how strongly each feature influences the prediction. We can see that higher income and credit scores negatively impact approval chances, while a higher loan-to-income ratio, more debt relative to income, increases approval chances. Here we have some explanation about why logistic regression is more appropriate than linear regression for binary classification. The key point is that logistic regression outputs values between 0 and 1, which we can interpret as probabilities. So the sigmoid function that logistic regression uses to transform linear predictions into probability values between 0 and 1. You can see that regardless of how extreme the input values are, the output is always bounded between 0 and 1, making it perfect for probability estimation. Now we'll use our trained model to make predictions on the test data. We're generating both class predictions, 0 or 1, and probability prediction. We'll make predictions on the test set, and then we'll display example predictions. Here we can have examples of the model's predictions. For each loan application in our test set, we have the actual features, income, credit score, and debt to income, and the true label, whether it was actually approved or rejected. Our model's prediction and the probability associated with that prediction. Of the first 5 results, all 5 are predicted as rejects, but 2 are accepted. Finally, we'll demonstrate how to use the model on a new loan application. We have an applicant with an income of $75,000, a credit score of 720, and a debt to income ratio of 0.25. Our model predicts that this application would be rejected with these current thresholds. So this wraps up how we use our logistic regression model for loan approval prediction. In the next video, we'll take a look at how to evaluate the model's performance using various metrics and visualization techniques.